Right triangle trigonometric application problems. Example 3. A paper cup for a snow cone has a radius capital R and a vertical angle of 60 degrees. When a ball of radius R is dropped into the cup, the top of the ball is even with the top of the cup. Determine an expression for the distance from the bottom of the ball to the vertex of the cone in terms of capital R and small r. Well, let's read the problem once again. Try to understand what is being asked. A paper cup of snow. So this is a paper cup snow, right? Like a cone. And here we are given a cross section of that, right? So think like this. So we have a cone like this, right? Kind of like this, right? And in that, a ball is dropped, a bigger ball. So it touches things like this, correct? Something like this, right? Now, the radius of this ball is small r, and the radius of this big cone is capital R. That is how you have to see the problem, okay? Now, and the angle here is 60 degrees. So this cross section, total angle is 60 degrees, so half of it will be 30, right? So let me write 30 degrees here and 30 degrees there. So this total of 60 degrees angle, correct? When a ball of small radius r, so that is the ball of small radius r, so up to here, is dropped into the cup, the top of the ball is even. So that is the top of the ball, which is even with the top of the cup. Determine an expression for the distance from the bottom of the ball to the vertex of the cone. So from here, that means this distance. That means we'll say P is this point, P and C. So this is what we have to find in terms of capital R and small r, correct? Because those are the known things to us, right? So how much distance is left at the end of this cone is this to be found, okay? So that's the problem. So let's try to solve it, and we will use we know r small r, so we'll use tan of 30 to figure out this expression, okay? So what we know here is a to m is capital R because the radius is r, right? And this radius small is, we'll call this point as q, okay? So OQ is small r. Now, what is tan of 30? So this is a right angle triangle, correct? Now in this right angle triangle, this is also a right angle triangle. In this big right angle triangle, tan of 30 degrees is equals to opposite, which is AM, which is R, divided by adjacent, which is this, MC. Let me write MC now, right? So what is this MC? MC is from here to here we have small r, then from here to here again we have small r, so two small r's, and then PC, the distance which we want to find, correct? So we can write MC as r over 2r plus PC, the one which we need to find, okay? Now this is what we got. Now what is tan 30? Well, we can always use our calculator and figure it out, but let's use the standard triangles for the time being. So in trigonometry, try to remember your standard special triangles at times called. This is a 60 degrees triangle. So we have 1, 2, and this side is square root 3, and that is 30 degrees, correct? So what is tan of 30? Tan of 30 is opposite over this. So it is 1 over square root 3. So I can write this as 1 over square root 3 is equal to capital R over 2R plus PC. Is it okay? So we get an expression, equation, which is relating R, capital small r, and PC. This is what we need, right? So let's simplify this expression. So let's cross multiply first. So we get 2r plus PC equals to square root 3r. Is it okay? Now let's isolate for PC, which we want, right? PC equals to minus 2r. So that is the expression which relates this side, the bottom which is left in terms of capital radius r and the small radius r of the ball, right? So that's our solution. So that's how we can do it. Now here I can give you a challenge problem, right? That challenge problem is really difficult. Okay, so to give you a hint, let's assume that we have this as an equilateral triangle. Okay, let me write that as 60 degrees for you now. Now if this is r, that means this is also r. Is it okay? So this total length is 2r, correct? That means this length and all these sides are equal, right? So we'll assume this to be 2r. This is for challenge problem, okay? These sides are 2r, right? Now you solve this problem using similar triangles. You will see that triangle AMC, right, that it's got 60 degrees here, 90 degrees there, and 30 degrees here, right? Triangle AMC is similar to triangle OCQ, right? I should say AMC, then I should say OQC, right? Because 90 degrees for a small triangle is at Q, right? So what you can do is that you know triangle AMC is similar to triangle OQC, and then you can equate the sides opposite to 90 degrees, right, to the sides opposite to the same angle, 30 degrees. So side opposite to 30 degree in big triangle is capital R, and in small triangle is small r. So the ratio of r over r is equal to ratio of 2r to this. Is it okay? And then also you get the same equation, correct? So you can try using that, okay? That's the problem for you. Thank you.